Hello everyone, welcome to Global Online Platform. I am Rahul sir, your management educator. We have done with the 2 units, that is international business and unit 5 financial management. So today we are going to start with the new unit number 8, statistics and operation. Here we have, in this crash course, we are going to discuss this unit. In the main feature of this unit is there is nothing, not much things to understand. You all that basically things are on rote learning basis. So today we are going to start with the introduction and measures of central tendency. Before starting, there is an important information for you that the UGC NET exam is very close. We are offering the UGC NET paper 2 management. If you take this course, you will get complete video lectures, full syllabus, notes, test series, and PYQ PDFs with explanation. This is going to be a target-based preparation. The main feature of this course is if you take the paper 2 course, you will get the paper 1 totally free. You just have to download this global online official app. After downloading and login, you will see this home interface. In this home interface, you have to select the store button. After scrolling, you will get the paper 2 management. This you have to select, and after making the content, you will be able to access all the contents which we have added here. There is option. There is also a search option in the store section where you can easily search the UGC NET paper 2 management. First, you have to, if you want to join the batch, you can contact on the given number, and if you have any query regarding the course, you will get the your query resolved by after contacting this number. So let's see what is statistics. Statistics is a branch of applied mathematics that involves the collection, description, analysis, and inference of the conclusion from the quantitative data. Remember this point, it can be asked, statistics deals with both qualitative and quantitative data? No. Statistics is basically concerned with the quantitative data only. It is the branch of applied mathematics which involves the collection, description, analysis, and inference. CDAI, collection, description, analysis, and inference it deals with. Okay. I hope this definition is clear. Now, we have 2 types of statistics. One is descriptive statistics and one is inferential statistics. Descriptive means what? You are just describing the things, and in inference you are finding out the conclusion. Descriptive statistics involves the organizing, summarizing, simplification, and describing the describe and present the data. But in case of inferential statistics, there will be generalization from the samples to the population. A generalization will be made from the samples to the population. Here it involves the hypothesis testing and predictions will be made. So inferential statistics involve the hypothesis testing sorry, the making predictions and generalizing the samples to population. I hope this is clear. Now we are starting with the important topic, that is measures of central tendency. Here in this measures of central tendency, the central tendency is stated as the statistical measure that represents the single value of the entire distribution. An entire distribution is there and a single value is representing it. It is called as mainly the central tendency or of the data set. Okay, it aims at to provide an accurate description of the entire data in the distribution. Whatever the data exists in the distribution, only a one single value can will try to give us the accurate description. This is called central tendency. Now, central tendency is further classified, or average. Central tendency is also called as average. So the average will be classified into 2 groups. Means one is will be the mathematical average, where mathematical operations will be used to calculate the average, and another is positional average, which is related to position of the average. Then here in case of mathematical average, we have the mean, which is of mainly 3 types: AGH, arithmetic mean, geometric mean, and harmonic mean. But in case of positional average, we have we have 2 things, that is median and mode. Median is the central value and mode is the most fashionable value. let's understand what are the measures of central tendency. The measures of central tendency, I hope I have told you, shown in you in the chart. So here one by one we are discussing. First one is the arithmetic mean. Arithmetic mean or AM is the called the average. It is just the ratio of sum of all observations to the total number of observations. It is the sum of the observation or to the number of observation. You are just calculating the average. Suppose I was showing you. Suppose here four numbers are given 2, 6, 8, 10, 9. So here you what you will do, you just 16, it's 16, 26 and 9, 35 and 35 divided by 5, that is 7 will be the center will be the mean. Okay, this is sum of the entire numbers divided by number of observation. Just like when we normally calculate the average, it is like that. Then the median is the middle number in the sorted ascending or descending list of the numbers that can be more descriptive in the more descriptive of the data set than the average. What does median do? Median, for calculating the median, you have to arrange the data in either ascending or descending order in a sorted form. Then you will be able to find out the middle number which is representing the whole series. It is median is a positional average. Okay. It describes the data in a descriptive way. Okay. Then we have mode. The mode is the value that appears most frequently in the data set. A set of data may have one mode, more than one mode, or no mode. Okay, then mode is just what it is also called as most fashionable value. Whenever you are studying in college or in school, there was a group which was frequently roaming here and there to gain all the information. So this is like that. The value which is frequently repeating in a data set, it will be called as mode. So mode will be mode will be the most frequent value. Okay, then a distribution can have either one mode or one greater than one mode, or no mode will be there. If whenever the mode is not able to represent the data set, it is called as ill mode. Okay, then we have the another two mathematical average, that is geometric mean and harmonic mean. The geometric mean is the average value or the mean which signifies the central tendency of the data numbers by finding the product of their values. Basically, we multiply the numbers all together and take the nth root of the multiplied numbers, where the n is the total number of the data values. Here what the same thing which have seen in the form of mean, we are doing the same thing, but what we are doing, we are finding the average by using the root sign, and the whatever the total number of observations are there, we will take the nth root. N is the total number of observation, and we will product all the numbers which are available in the data set. Okay, I hope this is the geometric mean. Then we have harmonic mean. Harmonic mean is defined as the reciprocal of the average of the reciprocals of the data value. Here the the data values will be we will do the reciprocal of the data values and find the reciprocal average. Okay, it is the mean which gives less weightage to the large value. It is the mean which gives less weightage to large values and large weightage to small values. Here the small values are given greater weightage than larger values. Okay, to balance the values correctly in general, so that the proper balance can be maintained between the values in a data set. Okay, in general, the harmonic mean is used when there is a necessity to greater weight to the smaller items. When the greater weightage is required for the smaller terms, we will use the harmonic mean. It is applied in case of times of average rates. It is used in case of times and average rates. Okay, one is also there, that is weighted means. in case of weighted means we use the weights. Weights are assigned to different observation and to find that mean. Then here we are starting with the properties of different measures of central tendency. This part is very much important from exam point of view, because this these properties become the base for statement wise question to find out the either correct or incorrect statement. Okay, these are the properties of arithmetic mean. Here we are discussing properties of arithmetic mean. The first one, a constant b is added or subtracted from every observation. The mean of this observation will also get added or subtracted. Here what it is talking about, it's just talking about mean will be affected by scale. Mainly there are two things. Sorry, it was origin. Mainly generally two things are there. One is origin and one is scale. Mostly people confuse among this, so I am telling in detail. So what does origin means? Origin means whatever you are adding and subtracting, and scale means the whatever the multiplication and division you are doing with the observation, it will be called as scale. So if you add or subtract to the arithmetic to any number in the data set, the whole mean will be affected. And if you on the another hand, if you will multiply or divide by any divide any of the observation in the data set, the whole value will be, the actual value of the mean will be affected. Why? Because mean is mean is dependent of scale and mean is dependent of origin. Okay, it is dependent of both scale and origin. Now let's see the second one. If every observation is multiplied or divided by the constant beta, the mean of this observation will also get multiplied and divided. It is same talking about that mean will be affected by both scale and origin. Okay. Then the sum of deviations from the observation from the arithmetic mean is always 0. Remember this point. The sum of the deviations from the observations from the arithmetic mean is always 0. Then the sum of the squared deviations of the observations from the arithmetic mean is minimum. The sum of the squared deviations of the observation from the arithmetic mean is minimum. Then third, the last point is arithmetic mean is capable of being treated as algebraically. Arithmetic mean can be algebraically treated. Okay. I hope you might have understood the properties of the arithmetic mean. Now let's discuss the properties of geometric mean. Geometric mean we have seen where we use the root values to find out the mean. Okay, the geometric mean for a given data set is always less than the arithmetic mean for the data set. Remember this point, that the GM will be less than the AM. Okay, geometric mean will be always be less than the arithmetic mean. Okay. Then if each object of the data set is substituted by GM, then the product of the objects remains unchanged. If each data set is substituted by using the geometric mean, the whole it will remain constant. Okay. Then the ratio of the corresponding observations, just a second. The ratio of the corresponding observations of the geometric mean of two series is equal to the ratio of the two geometric mean. Whenever we take the ratio of two corresponding observation in geometric mean, it will be equal to the ratio of their geometric means. Okay. Then the products of the corresponding items in the geometric mean in two different series will be equal to the product of their geometric mean. Okay. It's just talking about the scale and origin. If two different series, then if the observations will be multiplied together, then it will be similar to the multiplication of geometric means of those two series. Now here are the for all the three formulas, that is arithmetic mean, geometric mean and harmonic mean. Here arithmetic mean is just adding the values and divided by total number of observation. In case of geometric mean, you will find the root, that is under root 3a into b into c. Okay. Then in case of harmonic mean, you will just keep the number of observation in the numerator, and reciprocal the number will be done. The reciprocal of the actual observation will be done, that is 1 upon a 1 plus 1 upon b plus 1 upon c. So these were the formula. Now let's understand the properties of median. Median, we have seen that after ascending and descending order, after arranging the value in ascending or descending order, whatever the value we get, it is called as the median. It represents the center of the data set. So whenever the value which is representing the center of the data set in a proper in a sequence, when it is arranged in either ascending or descending, it is called as median. Okay. Now let's see the properties of median. Outliers and skewed data have less impact on the median. Outliers and skewed data have will not have that much impact on the median. Then if the distribution is skewed, the median is a better measurement as compared to mean. Whenever a skewness exists in the data set, means skewness basically means when the mean, mode and median are not equal, a bell-shaped curve is not formed. We will study further, don't worry. Then we have the median is best measure as compared to mean. Then median is not dependent on the dataset value of the dataset. Median is not dependent on all the values of dataset. Then fourth one is the median. The median value is fixed by its position and is not reflected by the individual value. Each individual value will not reflect the median. It will the median value will be fixed by its position only. Okay. The distance between the median and the rest of the values is less than the distance from the any other point. The distance between the median and the rest of the value is less than the distance from any number of points. Okay. Then every array has a single median. Every array means every data set will have only one median. Then median cannot be manipulated algebraically. It cannot be weighted or combined. There will be no weights cannot be assigned to medians, or they cannot be combined. That's why and no algebraic treatment can be done over the median. So it is positional average. Okay. Why? These are the main reason behind this behind the not doing the algebraic treatment is the because median is the positional average, not an algebraical method. Okay. Sorry, not a mathematical average. Then in a grouping procedure, the median is stable. Median is stable in case of grouping group data. Then median is not applicable to qualitative data. Median is already used to find out the in case of quantitative data. It will not be applied to qualitative data. Okay. Then the values must be grouped and in order grouped and ordered for computation. For computing the median, the groups and the observation should be arranged in a particular order. Then median can be determined for the ratio, interval, and ordinal scale. The median cannot be except the categorical scales, except the median can only be determined for the ratio, interval, and ordinal scale. Okay. Basically, it will starts from the ordinal scale only, where the data is arranged in a particular order. Now let's see the properties of mode. The mode is not unduly affected by extreme values. Mode is not unduly affected by extreme values. Then the mode is not calculated all over the observation of the dataset. The mode is not calculated on all the observations of the dataset, because what we will just pick up the value which is frequently repeating in the dataset. Okay. Then the third point is the value of the mode can be computed graphically, whereas the value of the mean cannot be calculated graphically. Graphically, value of mean can't be represented, but by by using the histogram, you can represent. You can find out the value of mode graphically. Okay. Then the value of the mode can be calculated in open distribution without knowing the class limits. Without knowing the class limits, mode can be calculated from the open-ended distribution. Okay, but then we have the mode can be conveniently found even if the frequency distribution has class interval of unequal magnitude, provided then the modal class and then the class succeeding and preceding are of same magnitude. Means what it is trying to say, suppose if there is any class here that is 10 to 12, 10 to 19, 20 to 21, in this case also you don't need to arrange this in close-ended frequencies. Here also you can, using the open interval data, you can determine the mode. Okay. Then the last one is, sometimes it may not be possible to calculate the mode. Sometimes mode is difficult to calculate because it if the data set has a bimodal distribution, if the data set has bimodal means what? Two modes will there, in which there is a two possible values for the mode. There can be two possible values for the mode. Now let's see the formula of the median. Median is what? Median, in case if the value number of observations are odd in number, then what you will do? You will just put the n plus 1 divided by 2. Okay, this will be done in case of n plus 1 divided by 2 will be done in case of median only. Then but in case of if there are even numbers of observation, when there are even numbers of observation, you will just do that x n plus 1 n divided by 2 will be one set, and n divided by 2 plus 1 set. Both will be added together to find the median in case of even terms. Okay, I hope. And hold the sum, and the sum will be also divided by 2. Okay, it can be either multiplied by 2 or the both of the summation of this n by 2 and n plus 1 by 2 can be divided by 2 to find out the median in case of even number of observations. Now, when there is a group frequency table, when there is a group frequency class interval type table is there, how at that time, how mean can be, how mode can be computed. Then here we will use this formula, that is L1 plus n by 2 in the whole bracket, n by 2 minus CF. In the denominator, we will divide it by the frequency and multiplied by h. It is the length of the class interval, means that 10 raised to 20 is the class interval. The h will be 10. Okay, there's difference between these two values will be the h. Okay. Then L is the lower limit of the median class. Whatever the median class will be chosen, L will be the lower limit of the median class. Then N will be the number of observations. CF will be the cumulative frequency of the class preceding the median class. This point you should remember, that cumulative of not succeeding class will be taken, the preceding class will be taken. Okay, F is the frequency of the median class and H is the class size. That is just I had shown you, if the 10 to 20 is the median class, the H will be difference between the two upper limit and the lower limit. It will be called as H. Okay, class size will be there. Now, in case of mode, we have seen the formula of all the three formulas in case of median. Now we will discuss the formula of mode. In case of mode, you can use this formula is quite lengthier, that L1 plus F1 minus F0 divided by 2 F1 minus 2 F1 minus F0 minus F2 into H. Okay, this is the way you can compute the mode in case of grouped frequency table, where L1 is the lower limit of the modal class. Here modal class, earlier we were considering, in case of median we were considering the median class, here we are considering the modal class. L is equal to lower limit of the modal class. H is the size of the class interval, assuming that all the class sizes to be equal. Then F1 is the frequency of the modal class. F0 is the frequency of the class preceding to the modal class. F0 means what? It is 0. It is 0 is 0 comes before 1. Na? So it will represent the frequency of the preceding class will be taken, and F1 will be frequency of that modal class, and F2 will be what? Frequency of the class succeeding to the modal class. Suppose here 10 to 20 is the your modal class. Then what you will do here, you will take the 0 to 10, you will take as a F. This will be your F1, this will be your F0, and this 20 to 30, this will be your what? This will be your F2. Okay, I hope this is clear. And H is the again the class size. Now we have we study the empirical relationships among the mean, mode, and median. In case of mean, mode, median, there is an empirical relationship exists. Here, the formula for this empirical relationship is the mean minus mode is equal to 3 mean minus median, or it can be also calculated by mode is equal to 3 median minus 2 mean. Okay, I am repeating this once again, that mean minus mode is equal to 3 mean 3 whole bracket mean minus median, or mode is equal to 3 median minus 2 mean. So that was all about your central tendency measures. We have covered everything in detail, all the properties which are most important from exam point of view. You have to just remember the properties and the formulas which become in statistics. Mainly these two things become the base for asking the question. I hope everything is clear. Related to central tendency. We will meet in next video again. Thank you. Bye.